Okay, so we're missing a few people today. Who are we missing today? Trenton? Where's Trenton? Okay, he's registering. We're missing Casey Gilbertson. Oh, so she might be skipping. Okay. We're missing Tyler. He's at band. Danny Mondial. Vandenhoevel. Student council stuff. Okay. All right. Okay, Unit 9.6 polar coordinates. You're going to need your calculator as well. Today is definitely new material. Again, that's the trouble. First semester is all review from the previous year. Second semester is all brand new material. Again, this is stuff you haven't seen before. And that just, presents difficulty a lot of times. So we'll do our best. I'm going to start with this example. X squared plus y squared is equal to 9. So if I have x squared plus y squared is equal to 9, do you know what that graph looks like? Do you remember? Who was your pre-calculus teacher from first semester? Fire that guy. Because if you don't know this, we're in trouble. What does it look like? Come on. X squared plus y squared is 9. What's the shape? It's a circle. Very good. It's a circle with a radius of 3. Because an equation for a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared, which is just, the distance formula, which is just the Pythagorean theorem. Remember, it all relates. So that is what we call rectangular form of an equation. And rectangular form because we have x, y coordinates. Now, if I wanted to type that into my calculator, can I type that in? No, I would have to solve for y, and I would get y is equal to the square root of 9 minus x squared. And I would get y is equal to negative square root of 9 minus x squared. Let's type that into our calculator. I've got the square root of 9 minus x squared, and I've got negative square root of 9 minus x squared. Okay, and now I'm going to go window, zoom 6, excuse me. I'll graph it in a normal viewing window. Does it look like a circle? No, that's because your screen's a rectangle. So if I go zoom square, number 5, it will, create it into its appropriate shape. And that looks much more like a circle, correct? But notice I had to enter it twice. Why did I have to enter 2 different functions in there? The bottom half, why do you have to enter the bottom half? Otherwise, it's not a function. It wouldn't pass the vertical line test. Well, there's ways to get around that. I mean, the calculator needs to be able to produce, given one input, it needs to produce one output. And we can use rectangular form in order to get around that, or polar form. And polar form, if you go mode, okay, and make sure you're working in radians. And then if you look down here, I have some different buttons. Okay, I have function, I have parametric, polar, and sequential. And we're going to do parametric later on, but right now we're going to go over to polar and press enter. Now, if you go to y equals, you can see that instead of having a y, you have a r. What is your radius value here? 3. I press 3 for my radius, and I press graph, and what do you know? Look at that. So the point is that you can, take this equation, x squared plus y squared is equal to 9. That is what we call rectangular form. And And it's rectangular form because it has an x-coordinate and a y-coordinate, and we have unique coordinates in that system. But we also have an equation, r equals 3, and that's what we call polar form. And that has coordinates r, theta. R is the radius, theta is the angle. And we call those polar coordinates. So your goal for today is to be able to plot polar coordinates and be able to name them appropriately. Are you ready? Let's begin with an example. When you plot polar coordinates, you should always do the angle first. Pi over 4. What quadrant does pi over 4 place me into? It places me in the first quadrant. Okay? So what I do is I turn pi over 4 units. Then I plot the radius. The radius extends 3 units. So if this was a 1, a 2, and a 3, 1, 2, 3. No, I suppose that would be about a length of 3. So that would be my polar coordinate right there. I just draw the line to actually show, that you have an angle of pi over 4. So that's an angle of pi over 4. That's a radius of 3. Are there any questions how I did that? Okay. That's one way to name that coordinate. Can I tell you another way to name that coordinate? Instead of going around pi over 4, I'm going to go around once more. So this is 2 pi, or 8 pi over 4. Would everybody agree? So if I go around to pi over 4 and I go around once more, I'll do that in green. That'll be pi over 4 plus 8 pi over 4, which is what? Right. So 3 pi over 4 is the same as 9 pi over 4, which is the same as 17 pi over 4. So on and so forth. Everybody understand that those coordinates are the same? Are there any questions about that? Okay, let's change it a little bit, okay? Because we add 8 pi over 4, or 2 pi, to each angle for traveling around again. So another one would be 25 pi over 4, and 33 pi over 4. Okay, you can also have negative angles, okay? So create another one. I'm going to end up at the exact same spot. I'm going to take a different approach than I did the previous hour. I'm going to go like this. Three and negative 7 pi over 4. I'm going to end up at the same spot. Watch. I plot the angle first. How much is 7 pi over 4? Do you have out your graphic organizer? Tara does. If you don't know these off the top of your head, you're going to have to 315. So negative 7 pi over 4 would start here, and it would bring you all the way to this position right here. And then you would extend 3 units in that direction. It's up to you, whatever you can follow along with. If you want to make another chart, you know, one for the blue, one for the red. That might be a good idea. Does everybody see that these are essentially the same? 3 in pi over 4 and then 3 negative 7 pi over 4, that those put you in the same spot. Okay, so in one case I have a positive radius and a negative angle. In the other case I have a positive radius and a positive angle. So if you wanted to go around again in the negative direction, you would add on a negative 8 pi over 4. What would your new angle be if you added on a negative 8 pi over 4? Negative 15 pi over 4. So that would also put you in the same spot. How about one more? 3 and negative 23 pi over 4. That was a horrible pi, sorry. Sorry. Okay. And we could go on forever, right? Are you ready for the tough one? We had a positive angle, we had a negative angle, but in both times the radius was positive. Now I'm going to make the radius negative. How can you have a negative radius? Well, in polar coordinates we allow for that. So I'll show you what that looks like. Okay. So now I'm going to do negative 3 5 pi over 4. So I always do the angle first. Which quadrant does 5 pi over 4 place me in? It places me in the third quadrant. And here's the deal. Now watch what I do here. I would want to extend it this direction. However, because it's a negative radius, I go in the opposite direction from there. So I go in the opposite quadrant. I skipped right over the origin. So I go 5 pi over 4, but because it's a negative 3, I'm going to go that way. And I end up at the same place I was before. So that's what always gets people, is that negative radius. And we'll practice this. First hour second hour we did 8 practices in class where we plotted them. Just let me get through the last set here, then we'll practice. But I could go around even more times than that, right? And so we could have negative 3, and you could add an 8 pi over 4 onto that and get 13 pi over 4. Or add an 8 pi over 4 onto that and get 21 pi over 4. So right now, I've got 9 coordinates on the board that are all the same. They're all identical. So which example haven't we done yet? Negative, negative. Okay, so I'm going to do that right now. We'll do a negative, negative. And what I'm going to do is I will do negative 3 and negative 3 pi over 4. Okay? And so I'm naming these all the same, kind of in my head. And that's what you'll learn how to do today. So I've got negative 3 and negative 3 pi over 4. Which quadrant does negative 3 pi over 4 place me in? The third quadrant. It starts here and brings you to right there. And it wants to extend 3 units in this direction. But it can't because it's a negative radius. So therefore it goes opposite direction and places me right there. Now, instead of just going around negative 3 pi over 4, I could continue and go around the pole more than once. No. I'm just showing you how all of these are the exact same as 3 pi over 4. So I could go around more than once in the negative direction, and I would just, add on another negative 8 pi over 4. So I had negative 3, negative 11 pi over 4. And I would have negative 3, negative 19 pi over 4. And obviously there's an infinite number of choices for each one of those. So I just took one coordinate, 3 pi over 4, and I named it 12 ways. and they all put you in the same exact spot. Are you ready to practice plotting these on your own? Okay, so I'm going to give you some examples, and we'll see if you can do it. So on your own, plot the following. Okay. See if you can plot those. I'll come around and check to see how you're doing. Okay, let's check here, guys. Let's see how you did. They call the origin the pole because you rotate around the pole. And so I'll do the first one in blue. We have 1 3 pi over 4. So I sketch 3 pi over 4, which is going to place us right here. And I go 1 unit in that direction. And so it would just be that coordinate right there, approximately. I'll do the next one in red. 3 negative pi over 6. Negative pi over 6 is going to be negative 30 degrees. And so I would just go down a little bit, and I extend out in that direction 3 units. So something like that. How'd you do there? Okay, negative 3 and negative 3 pi, I'll do that in green. Well, negative pi is going to be here. Negative 2 pi, negative 3 pi places me right there. And then if it was positive 3, I would extend 3 along the negative part of the x-axis. But it's a negative 3, so instead of going to the left, I'm going to go, in this case, to the right. Ask. Alex, should I show that one again? Okay. So I have negative 3 and negative 3 pi. So as we draw the graph, I have to first do my angle. Negative 1 pi, negative 2 pi, negative 3 pi. Yes? Now, if it was positive 3, I would extend it in that direction 3 units. But it's not. It's a negative 3. So instead of extending it in that direction, I go the opposite direction, 180 degrees in the opposite direction. So the red is the correct graph there. That help? Okay. And then the last one would be negative 4, or positive pi over 4. So I first go positive pi over 4, which places me right here. But because it's a negative 4, I go 4 units in the opposite direction, so you should have that kind of a shape. And there's my 4 points I plotted. What do you think? Okay. Let's just start working then. That's it. Tomorrow we'll do more difficult stuff. Oh, that was calculus. Oh yeah, yours is on the board. Okay, but YouTube Nation can't see that. So unit 9.6, page 782, numbers 1 through 6. So that's it, numbers 1 through 6. Tomorrow, hey guys, tomorrow will be a full day of content. You got to be ready for it, okay?